can do some problems with both. So here's our first one. We'll start off nice and gentle. Secant squared theta minus 4 equals 0. And let's be on 0 to 2 pi. Hi, thank you. Madam President. I hear there's a math meeting tomorrow at lunch. It's not my math club meeting. It's math club's math meeting. I don't know what they're doing. Why is there a math club? Well, don't worry. He's the one who wanted to kill 30% of the population 2 days ago. No, it's an open club. I saw the announcement. It said new members welcome. Ouch. He just had a heaping bowl of something this morning. Yeah. Let's go. I like that so far, but you might want to pull the plus and minus in front so you're not confused by it. Hey, Stephanie, any questions? Answer looks great. Fabulous. Nice. When I take the square root of both sides in an equation, I must remember the 5, 4, great job. Okay. Why don't you say cosine theta equals plus and minus 1/2 then? All right.
I erased my work.
Oh. Well, that's special. How's it going? That's great, but there's 2 more answers. Okay. 5, 4, 3, and now flip those. Flip them. Cosine equals 2, 1. We have pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Very nice. How did... I added 4 to both sides and said secant squared equals 4. That's the same as cosine squared equals 1/4. So I took the square root of both sides and got plus and minus 1/2. Okay. Ben, how are you? All right, Dylan. I like the construction of that sentence. I found it very informative. especially the way you delivered it. I thought there was great emphasis available. Okay, so next one, let's have all solutions to this one. Square root of 3 plus 2 sine theta equals 0. And we're looking for all solutions, not just 0 to 2 pi. Question? How far is it from this solution to the next one that looks like this solution? So I like the plus 2 pi n's, but I got a problem with this line. I do. Which is going to change that line. How's it going? How did this become a positive? Did you use your own brain or look at it over someone who got it wrong?
I actually didn't look at his.
Then you made the same mistake he did. You forgot to subtract root 3 from both sides. How's it going? Whoa, little guy. Don't square both sides. That makes the problem much harder. Just subtract the root 3 and divide by 2. That's questionable. 5, 4, 3, 2. Birthday girl's almost done. One. We've got 4 pi over 3 plus 2 pi n and 5 pi over 3 plus 2 pi n. How many times is my sine graph going to equal negative root 3 over 2? Just twice? No. We know that this sine graph equals negative root 3 over 2. A whole lot of times. And you found this one here at 4 pi over 3. And you found this one here at 5 pi over 3. But we've got these, and we've got these, and there's an infinite number in both directions. And so how far is it from this one to one that looks just like it? 2 pi. And that's why it says 2 pi n. If the distance between the ones that look just like each other was only pi, then I'd do plus pi n. Okay? Tom, any questions? Okay. Yes, Ben? Yeah? I don't do it when the period of the function isn't 2 pi, which means I do it every time the period is 2 pi. If the period is not 2 pi, then I don't do it. I do something else. Okay? Okay. Cool. Maybe we should do something tangenty then. Tangent squared x sine x equals sine x. And please don't divide here. And let's go with all solutions. Does anyone want to explain why I said don't divide by sign here? I'm sorry, I didn't hear the three of you all at once. You're going to throw away solutions if you divide by a trig function, so don't divide by a trig function. I like that work. How did you go from that? Oh, you're doing that. I'll leave you alone. Okay. So this is for the signy stuff? Okay. Gotcha. How's it going? You thought to set the equation equal to 0 by subtracting sin x from both sides? Sounds like a really good plan. How's it going? Excellent. How about factoring? Is there a GCF you could factor out? Yeah. One from each. That's called factoring. There's two terms there. I want you to factor something out of each of those terms. You suggested a sign. I thought that was a good idea. That's perfect. Now, solve. Yeah, that's perfect. That's an answer. Mine's a little different than hers. Yeah. Yeah. That works. Wait. The distance from this one to this one is, so if you're just adding pi each time, aren't you picking up that one? If you had written 2 pi, 2 pi, 2 pi, 2 pi, then I would need all four. But if you're going to go with pi, because the period of tangent is pi, you only need the first two. Yep. How's it going, Ben? Okay, what do you got, Ben? Okay, tangent, sine, minus sine equals 0. And then you said you factored. Okay. Zero, pi, and so on. Great. So now how do we take the step about writing the general solution rather than just the solutions on 0 to 2 pi? Okay. How far apart are these solutions? I'm sorry? Pi. So we could do 0 plus pi n. If I plug in a 1, that generates this. If I plug in a 2, that would get the next one. So this is just for the siny stuff. Now let's come over here. How far apart are these? Some of them are pi apart from each other. No. 3 pi over 4 minus 1 pi over 4 is pi over 2. 5 pi over 4 minus 3 pi over 4 is, I know, it's hard. But remember, there's no assigned seating in this room, so you choose this experience. 5 pi over 4 minus 3 pi over 4 is, which is pi over 2. So the distance between these is pi over 2. And so I could write pi over 4 plus pi over 2n. But let's imagine that thinking wasn't something you wanted to be doing. You know, you could look at each of these and say, hey, couldn't I write pi over 4 plus pi n and 3 pi over 4 plus pi n and 5 pi over 4 plus pi n and 7 pi over 4 plus pi n. And what would the problem with that be? Yes? Yeah, they're duplicates. It makes you look like a bumpkin. The distance from this one to this one is pi. So why do you have this? I don't need this. This is covered by all of these. The distance from here to here is also pi. So I've already got all the pi distanced ones taken care of. So I would only need those two. Ben, do you have a question about this? Okay, starting to get a better sense of the n stuff. So, okay. The distance between those solutions you can think of as the effect of the period. Okay. So why don't we do this next problem both ways. First, we'll do it on 0 to 2 pi. Second, we'll go back and do all solutions. 2 cosine 2 theta minus root 3 equals 0. Remember, first we're doing 0 to 2 pi. Please don't reach for a double angle formula here. You'll only be sad. That's great. Think about the times when cosine is positive root 3 over 2. One of them's in first quadrant. Where's the other one? You got one of the 4 answers. Or you got the start of one of the 4 answers. Yeah, I'm holding on. Oh, come back. No, definitely not. Why do you have that 5 pi over 6? No, it doesn't, because cosine is negative there, and he's got a positive cosine. That's not in 0 to 2 pi. Okay, now you have the start of the first 2 solutions. Hi there. What's the effect of the 2 on inside the function like that? What does that 2 transformation do to the function? Megan? Well, I know I'm going to go around the circle 2 times, but he's wondering why. So I'm asking the question, hey, what if this were absolute value of 2x? Or what if this was square root of 2x? What's the role of the 2 inside the function when being multiplied? Divide all the x's by 2. So what's that going to do? That's going to squish my graph by a factor of 2. So how many graphs can I now squeeze into 0 to 2 pi? Instead of 1 cycle, I can now squeeze in twice as much. I can squeeze in 2 cycles. If 1 cycle was going to give me 2 solutions, 2 cycles will give me 4 solutions. And Megan's right when she says if I see that 2 in there in trig land, I know I'm supposed to go around the unit circle 2 times picking up solutions. So I end up with 4 possible solutions. 5, 4, 3, 2, 1. Brendan, you got pi over 12, 11 pi over 12, 13 pi over 12, and 23 pi over 12? Sweet. Good. Tom, any questions about this? So how far is it from this one to this one? 12 pi over 12? So how far would it be from this one to this one? Right. So 11 plus 12 gives me 23. You know, maybe one way to think about it, Tom, would be to say, look, I know that cosine is supposed to be equal to root 3 over 2. And I know that happens here in first quadrant at pi over 6, but also down here in fourth quadrant at 11 pi over 6. But that's only going around the unit circle once. And we know the effect of this too is to squish the graph in half so I can get twice as many periods in here. So if this was what I got from one period, there must be 2 other solutions for my second period. So as I go around a second time, I'm just going to add 2 pi to each of these. So 2 pi added onto this one is 12 pi over 6 plus 1 pi over 6, or 13 pi over 6. And 2 pi added onto this one would be 12 pi over 6 added to 11 pi over 6 for 23 pi over 6. But this is what 2 pi is, 2 theta is. We want to know what theta is, so we divide everything by 2. And we get theta equals pi over 12, 11 pi over 12, 13 pi over 12, and 23 pi over 12. We get those 4 solutions. Any questions about those 4? Okay. Will you please do the all solution case now? Yeah. It says when convenient. Why are you asking me? I don't know what convenient is to you. You know what we're doing today, just this. All right. I'll see you in a bit. 5, 4, 3, 2, 1. Some people have pi over 12 and 2 pi n, and some people have pi over 12 and pi n. I have pi over 12 plus pi n and 11 pi over 12 plus pi n. So let's talk about these. Remember that part that Megan said about going around the unit circle twice? I don't do that when I'm making all solutions. I just know that 2 theta is equal to pi over 6 plus 2 pi n and 11 pi over 6 plus 2 pi n. But I don't want to know what 2 theta is equal to. I want to know what theta is equal to. And so I get pi over 12 plus pi n, 11 pi over 12 plus pi n. Any questions on getting those solutions? Okay, so divide sooner. Or build the model sooner so that you divide everything. Okay, cool. Ben, any questions about the pi n stuff? Sweet. Okay. So why don't we continue with that theme with 2 cosine squared 3 theta plus cosine 3 theta equals 0. And let's go back to 0 to 2 pi. I got 9 answers. 9. Did you go around 3 times picking up solutions? I see once. No. Cosine is equal to 0 at pi over 2, 3 pi over 2. Go around 3 times. 5 pi over 2, 7 pi over 2, 9 pi over 2, 11 pi over 2. Then set all those answers equal to 3 theta and divide all of them by 3. I don't think you're going around 3 times picking up solutions. Birthday Darity, any questions? Okay. How's it going, Zach? I didn't have negative 1/2. Oh, I dropped my 2. Thanks, good catch. Oh, I guess there's more than 9 solutions. All right. Negative 1/2. 2 pi over 3. 4 pi 3. 8 over 3. 12 solutions, huh? 10 pi 3. I don't have 12 pi over 3. I have 14 pi over 3 and 16 pi over 3. And then divide all of those by 3. Whew, boy. Theta equals 2 pi over 9, 4 pi over 9, 8 pi over 9, 10 pi over 9, pi over 9, 16 pi over 9, and 12 pi over 6, 3 pi over 3, 9 pi over 6, 11 pi over 6. Yeah. I'm going to sit down because I'm going to try and make sense of what I'm looking at. What am I looking at? These are the first two solutions. But if I go around from this one once, I'm not at pi over 6. You didn't add 2 pi to each of these. So that one, if that one's pi over 2, and that one's 3 pi over 2, this one should be 5 pi over 2, and then 7 pi over 2, and so on. That came from setting this factor equal to 0. You're still working on this factor equal to 0. Okay. 5, 4, 3, 2, 1. So I've got 2 pi over 9, 4 pi over 9, 8 pi over 9, 10 pi over 9, 14 pi over 9, 16 pi over 9, pi over 6, 3 pi over 6, 5 pi over 6, 7 pi over 6, 9 pi over 6, and 11 pi over 6. Anyone need me to go through this with them? Yeah? Were you able to factor this? So you got cosine 3 theta to cosine 3 theta plus 1. And then we set each factor equal to 0. Okay, so when does cosine equal 0? Yes, very good. So 3 theta equals pi over 2 and 3 pi over 2. But what did Megan say about that 3? To go around 3 times. So I add 2 pi to that, and I get 5 pi over 2. And I add 2 pi to that, and I get 7 pi over 2. And I add 2 pi to that one, and I get 9 pi over 2. And I add 2 pi to that one, and I get 11 pi over 2. But I don't want to know what 3 theta is equal to. I want to know what theta is equal to. So I have to divide everywhere by 3. And so that gives me pi over 6, 3 pi over 6, 5 pi over 6, 7 pi over 6, 9 pi over 6, and 11 pi over 6. But that was only taking care of this factor. We need to now take care of this piece of information. When is cosine equal to negative 1/2? No. That's when sine is equal to plus or minus 1/2. 2 pi over 3, 4 pi over 3. And I add 2 pi to each of those, and I get 8 pi over 3, and 10 pi over 3, and 14 pi over 3, and 16 pi over 3. But again, that's what 3 theta is equal to. I want theta, so I have to divide everywhere by 3. I get 2 pi over 9, 4 pi over 9, 8 pi over 9, 10 pi over 9, 14 pi over 9, and 16 pi over 9. Kaylee, any questions on this? Okay. All right. Cool. Starting to remember some stuff now? Cool. That's exactly what the day is for. Okay. How about this one? Sine squared theta plus sine x minus 6 equals 0. Oh, wait. I meant to do that last one with both. No. I'll let Ben call it. Ben, do you want the all solutions on the last one? It's right here. He did say no. I don't know why you think it's so hard though. I thought the all solutions case was easier though. Pi over 2 plus pi n and 2 pi over 3 plus 2 pi n, 4 pi over 3 plus 2 pi n. Look, we're just one step away. So theta is pi over 6 plus pi over 3n, 2 pi over 6 plus pi n, and 4 pi over 6 plus pi n. What did you say? 9. Oh, threes. Thank you. Good catch. Yeah. Did I? It was this, and over 3. Thanks. Yeah. It's that same dividing by 3 issue I had here. Okay. So I don't see that as, like, why is that a big deal? Oh, okay. All right. Well, here's the next one then. And let's have all solutions here. Oh, yes, they are. Which one would you prefer? So much for Greek letters. Yes. 5, 4, 3, 2, 1. So we get no solution because when we think about the sine graph never goes down to -3, nor does it go up to +2. Okay. How about this one? Sine x equals -0.4 on 0 to 2 pi. It's -0.4. Yeah. 5, 4, 3, 2, 1. Are you in radians? I got 3.553 and I got 5.872, which is pi minus inverse sine of negative 0.4 and 2 pi plus inverse sine of negative 0.4. Sure, I just graphed sine. I graphed negative 0.4. I did second calculate intersect. Okay, that makes sense. Second calculate. Okay. Any questions about this one? So, Kaylee, what people are seeming to say is graph this in y1, graph this in y2 on this viewing window, and see that we have 2 points of intersection, and you do second calculate. Number 5 is intersect here and here to generate decimal approximations of those two answers. Let me go back and look. I got 3.553. So sine x, negative 0.4, graph. Oh, you need to see the camera. So here are the two functions. If I go second, calculate, intersect, and I bring my calculator cursor close to that first point of intersection and hit enter once, twice, thrice, I get 3.553. Okay. Yeah. Yeah, that's really old school, huh? Oh, lucky you. Sorry, this was inflicted upon me when I was young because we didn't have the magic box. Yeah, I don't have the expectation that we're doing this. This is something that I would find appropriate in an honors trig class for sure. I would devil kids with this. In a regular trig class, I'd show them, but I wouldn't expect them to do it. Yeah, decimal approximations is what we need. Really, what the conclusion I want you to be drawing is, I don't know this from the unit circle. I need to figure it out another way. And it prompts me and you to pick up our calculator. Kaylee, you all set? Okay. All right. Cool. How about we can get one more in? How hard of one do you want? Yeah, my moral compass. Go. What do you want? Medium. Okay. Medium problem. 6 sine squared theta minus sine theta minus 1 equals 0. And let's do 0 to 2 pi. But likewise, Stephanie, if there are answers that could be unit circle values and you give decimal values from a calculator saying, I don't know those unit circle values, you probably lose those points. So you should only be using this for the things that aren't unit circle values. You should have 4 solutions. Bell's about to ring. 3.481, 5.943, pi over 6, and 5 pi over 6. 2 I know from the unit circle, 2 I don't know from the unit circle that I need my calculator for. Yes, Grant? Yeah, this foils to be 6 sine squared. Grant, a question? Okay. Okay.